Good day everyone. The theme of our idea is constructing efficient flood resistant and bank protection structure by manufacturing fiber reinforced composite material from waste glass. Bangladesh is a riverine country and as a result it is very prone to flooding. The principal sources of flood are the overbank flows of major river system Brahmaputra, Padma and the Meghna in the monsoon season. In spite of constructing levees, dikes and spars, flood control reservoirs, dams and barrages, floods are becoming unavoidable. For a developing country like Bangladesh, constructing concrete walls at the bank of the rivers would be much expensive. Again, polders in the coastal area sometimes fail to meet the demand. After lots of researches, scientists and engineers have come up with a more feasible and reliable solution, and that is flood barrier constructed from fiber reinforced composite. It is a next generation innovation. It is very effective in protecting the urban cities and rural areas as well as slums, saving life of people, livestock and other animals. It also saves gardens, farming lands and all sorts of crops. It even overcomes the limitations of bamboo-built mandrel-like structures in riverbank protection. Glass fibers, which are mostly used as fiber reinforcement, can be easily manufactured from waste glass bottles and broken glass. Glass bottles are recycled and used in Dormagen, Germany. In this process, at first, the recyclable glass should be placed at curbside bins. Glass from material recovery facility and drop-off locations should be sent to glass processing company. Their glass is crushed and turned into cullet. Then chemical additives should be applied. In the industry, the cullet is sorted, cleaned and prepared to be mixed with other raw materials, and glass pieces are melted in furnace.
From molten glass, monofilaments are drawn and then gathered to form strands. Textile glass fibers begin as varying combinations of crystals of silica, alumina, boric oxide, quicklime, etc. in powder form. These mixtures are then melted by directly heating them at temperatures of around 1300 degrees Celsius. These filaments are then wound into larger threads and spun into bobbins for transportation and further processing. Roving is a process where filaments are spun into threads of larger diameter.
It can be achieved through several processes, including compression molding, ladder molding, wet layup, mandrel molding, chopper gun, autoclave, and vacuum bag, filament winding, and pultrusion. Among them, most popular method is pultrusion. Pultrusion is a manufacturing technique for fabricating continuous FRP structural shapes without altering the cross sections. In the forming process of a rigid structure is usually used to establish the shape of FRP components. Thus, FRP components allows alignment of the glass fiber of the thermoplastic to suit specific design panels. Flood barrier constructed from this composite requires much easier maneuver. It is less expensive than concrete and lightweight, easily removable and recyclable. Government should not waste time and take steps to install this type of flood barrier and encourage the recycling of wasted glass.